Hi folks, my name is Barnstedt. I'm the Chief Architect for Standards and Consortia in Azure IoT, and today I want to talk to you a little bit about how to avoid vendor lock-in and a practical guide and how to achieve that. So, first of all, you're probably familiar with vendor lock-in. It happens when you're forced by one of your suppliers to use a closed source SDK or some sort of proprietary interface that they make available to you. Sometimes they only allow you to communicate through a proprietary communication protocol. Um, Sometimes there's the data model or the data format that is proprietary. Or then, you know, more subtly, sometimes there's a certain number of data centers or, on-prem assets that you need to purchase that are mandatory for running the software, right? And then, of course, if any of that happens, you'll be locked into that vendor forever, right? Until you switch off the solution. So, how to avoid it and what you need to, you know, really require from your vendor for this to not happen to you. So, first of all, obviously, we're here on OPC Day. OPCUA is the industrial interoperability standard that Microsoft's been supporting from the start, and we've been putting OPCUA into our Azure product since 2016. And the reason why we think OPCUA is so important is because it gives you interoperability, gives you an open, extensible data model, and best-in-class security, which is really important also when you're talking about cloud applications. And regarding the data models, I mean, there's bound to be a standardized data model for your industry out there already because there's so much um, momentum behind building these data models right now. So really, no matter what industry you come from, chances are there's something out there already, and all of them are available free of charge from the OPC Foundation website and the specification that is, and the data models themselves are on GitHub, so you can just download them. Here's one from the oil and gas industry. As some of you may know, I'm currently involved in a carbon capture and storage project with some of the largest European oil and gas companies. It's called Northern Lights, and one of the data models we're looking to leverage is this MDIS data model. And as you can see here, there's going to be a pipeline of CO2 um, sent to the sea floor, and it's going to be pumped by something like this device here underground and stored forever in a safe location for permanent storage. So it's quite an interesting project, and of course we're going to leverage OPCUA for it. So there's so many consortia out there, and every time I blink, there seems to be a new one. It's kind of hard to really get a feel for who they are and what they do. So in general, when it comes to industry 4.0 or industrial IoT in Europe, there's the Platform Industry 4.0, which started in Germany but is now really a European initiative. And there's a number of input organizations that feed into the Platform Industry 4.0, and the OPC Foundation is one of them. Right, here are the others. Um, and then the platform creates a reference architecture and makes recommendations on how standards from the input organization should be leveraged. And then there's a number of user organizations that leverage some of the standards that the platform recommends. And the most popular ones here are Namur, Umati, now also Gaia X, the Labs Network, um, the IDTA, and the Industrial Data Space Association. So they're getting a lot of press right now because they're making some big strides into leveraging some of the recommendations, architectures, and standards from the Platform Industry 4.0. So what does that mean in terms of standards for the platform industry for a reference architecture. Well, OPCUA is mandated as the information model and the communication um, infrastructure for client server communication. Um, Towards the connected world, towards the cloud, OPCUA has been extended in 2017 with PubSub. So the area in gray here is now PubSub. The asset administration shell is something that the platform industry for O has been driving for a number of years. It's really a container format um, and a data sharing service, right? Um, of course, because OPCUA is mandated by the platform, there's a mapping to OPCUA available, and the trick with leveraging the asset admin shell with OPCUA information models is that the information model should stay intact. So really, um, you know, how to achieve that, you can find a sample that I built on my personal GitHub account here, github/Barnstedt, and you'll see how to leverage that. So the trick is really to keep the OPCUA information model intact as you transfer that information model from one cloud to another, from one vendor to another along the industrial IoT supply chain. Okay, so in terms of practical guide, really, you got to ask yourself 5 questions. If you can answer those 5 questions, um, you will be successful, or you have a better chance of being successful in your industry 4.0 project without getting locked in by your vendors. So I'll go into those questions now one by one and give my opinion of what is important when you're asking these questions to your uh, to your project lead and then also to your vendor. So really, question number one: what data model will you pick? Right. So really, people talk about data being the new oil. It's not the data; it's the data model that's the new oil. If a vendor dictates a certain data model, which is most of the time proprietary to that vendor, you're getting locked in, and you want to avoid that, right? So really, um, you know, demand IEC standards for your data models. OPCUA is such an IEC standard. And I also find, lots of people talk about their technology as being standard or standards based. Be careful there. If it's not an IEC standard, it's not a standard. Or, there's other standard organizations. OASIS is also a standards organization. DIN is a standards organization, but, um, for example, the Eclipse Foundation is not a standards organization, and lots of people contribute their technology to the Eclipse Foundation and claim that it's a standard. It's not, right? Be careful there. Um, Also, what happens a lot is that you get asked to remodel your assets in the cloud, right? So again, that's a telltale sign that you're getting locked into a proprietary data model. Don't do it. Demand that you can leverage your existing standards-based data model or model your assets using a standard and then demand support for that standard, right? Um, Worst case, right? If the vendor says, I can't redesign my entire product, ask for an import tool at least. So you can leverage your existing standard and then, import your standard based data model into whatever service that the vendor offers, and then also demand to get the data back out when you want to, right? So kind of standard data in, standard data out, right? So that's number one. Number two, where do you want to normalize your data? Well, guess what? When you're doing cloud analytics, you'll have to eventually normalize all your data into a single format, right? A lot of people think as long as I can send the data to the cloud somehow, it doesn't matter how I'm done, right? Problem solved. No, it's not. That's where your problems start, right? So you want to um, convert your data preferably to a standard based format as soon as humanly possible. Um, the best place for that to happen is at the edge before you even send it to the cloud, because the edge is usually per production line or per plant, um, part of a plant, and then you don't need to scale to the massive scale that your cloud application will have to scale to when you're connecting all your assets, all your plants, and all your factories to the same cloud, right? So that is definitely a better place to do it. Um, and again, formatting that data once is the key. And it's also usually a lot easier to find somebody who actually understands the data locally on the factory floor, right, or on in the plant, rather than getting some of your IT folks to make sense of the data in the cloud later on. Question number 3: what telemetry format will you pick? Right. So, if I had a penny for all the times that some sort of industrial IT expert has, you know, talked about their latest hip and trendy discovery regarding, a super efficient format and how they've tried it out on a Raspberry Pi and it worked great and all this, just don't believe it, right? Really, the most efficient way of sending data long term is by using a standard format because it gives you interoperability, right? And you also have a good chance that the data format will be supported natively by the services and cloud databases that you're going to use. Because really, if you're sending the data in some other format and then you need to um, re-encode the data in the cloud, again, you have to pay for that re-encoding, right? And it adds no value, right? Best case scenario, you're converting the data into a standard format on the edge, and that format is natively supported by your cloud application. That's why OPCUA pops up as such a good format, because it defines a standardized JSON encoding, and every single service and database in the cloud these days supports JSON. Right, that is a huge value saver right there, or cost saver. Okay, next question: how much scale do you need? Right, so a lot of times people pick um, their projects too small or too big, and then they run into problems. So the best thing to do is to start small, start with a small POC, and then scale that out. And the trick is to use services in the cloud that auto scale, right? If you need to basically keep an eye on your services all the time just to make sure they don't run out of juice, that's not a great job description, right? So you want to be able to auto scale those services if at all possible, and figure out the use case before you start building an architecture, because a lot of times folks built this massive architecture, and then they end up not using it, and because their use case is much simpler than they thought. Then the next one, um, do you need to integrate third-party enterprise systems? Most of the time that answer is yes, right? So you really need a separate mechanism for those additional asset telemetry streams. Historians are notoriously hard to connect to because they usually have a proprietary interface. Thankfully, there's OPC Foundation partners like Matricon and Softing that have connectivity software for those proprietary interfaces. They also, obviously offer an OPCUA interface on the back end, so you can connect through OPCUA to those software assets, and it makes it much simpler than to again do that data standardization. Um, Similar with ERP systems, they usually have proprietary interfaces, and you just need to bite the bullet and create a converter, right? Extra points for converting into a standard format. So then those were the 5 questions you should answer, and just just bear with me here because I get this all the time and I can't say it often enough. This whole OPCUA versus MQTT makes no sense, right? So OPCUA is platform and protocol independent. It has a mapping um, to MQTT. That mapping existed for 4 years now. It's part of the IEC standard, OPCUA, and you know we're going to continue to leverage more features of MQTT as they become available. For example, MQTT v5 has a few extra features regarding routing and so on, and of course OPCUA is eventually going to make use of that. Um, so this whole efficiency conversation comes up from time to time. We've been using OPCUA PubSub with MQTT since 2015 for the last 6 years, and we found it very efficient at Microsoft. It's also very cost effective. So, I mean, don't believe everything you read, um, on the internet. If it's on the internet, it must be true, right? So anyway, don't believe it. It's very efficient, and we've been leveraging it in a lot of large scale customer projects very successfully. So what does the Microsoft Industrial IT Stack looks like? So nothing's really changed there. Most folks that know me have seen this slide before. So, our cloud is split up into layers. So at the bottom, you have your infrastructure, your, databases come on, one layer above as PaaS services. So managed services, Microsoft manages those services for you. Then on top of that, we've built our, super efficient interoperability layer based on OPCUA, and that's the OPC Publisher, the OPC Twin, and all the other OPC services that you're probably familiar with by now. And then on top of that, if you want a turnkey solution, we also have a software as a service offering now, which is IoT Central. Time Series Insights has its own dashboard. Power BI, obviously, no code dashboarding functionality. So if you want just to log in and start, playing out of the box, you can do that too. And as a partner, you can build on any of those layers. Every single one of them is optional. So you can base your own industrial IoT platform on our infrastructure if you want to, or you can, just reuse some of the higher level services. In general, end users want, managed services because they don't want to manage those services themselves. And Microsoft takes pride in actually doing a lot of the and keep extending the services that we offer, and creating new services that we manage. So what does a normal industrial IoT data pipeline look like, which leverages OPCUA? Well, here it is. So you have your assets on the left. They could be aggregating assets, so several physical assets connected to one aggregating asset using an OPCUA server. Then you have some sort of edge gateway. We have IoT Edge, of course. Then we have the cloud gateway, which we call IoT Hub. And then we have our time series database, which is called Azure Data Explorer. And this entire pipeline up to and including the time series database is based on OPCUA PubSub, and it can understand that data natively, no data conversion required. And then, of course, you can connect your machine learning or Synapse to that database and do some predictions, write some Azure functions, which is a serverless compute service that we offer, and then even create a digital feedback loop based on IoT Hub methods. And those methods are then translated back to OPCUA method calls on the edge. And unfortunately, still almost everybody else, not everybody else, but almost everybody else doesn't do that. They still leverage OPCUA just to collect data on the shop floor and nothing else, which I think is a shame because, again, it doesn't leverage open standards and locks you in. So there's a separate talk on this topic, so I'll just briefly mention it here. We have this thing called the UA Cloud Library, which is kind of the missing piece in this entire telemetry pipeline. It allows you to upload OPCUA information models to the cloud and leverage them, read them on demand as you're doing your analytics, which which is kind of handy. So your time series data can be just the time series data, and to look up the information model that is associated with that particular time series, very soon you'll be able to leverage the cloud library. So we're working on releasing the spec. It's in draft. It's in review right now with the OPC Foundation, and hopefully we'll be able to release it soon. And then, um, we've also started some POC prototype implementations of it already. And of course, we're going to open source them, and you can make use of it then. So very briefly, you should be familiar with this. So we keep growing our brownfield connectivity partnerships with additional partners that are leveraging IoT Edge, and building OPCUA enabled connectivity solutions containerized on IoT Edge. Here's a list, and again, they're on the Azure Marketplace. So in terms of very basic connectivity, you don't need a lot of services at all. Edge is free, OPC Publisher is free. You can leverage the connectivity adapters I just mentioned from the Edge Marketplace, and then all you really need is an IoT hub. In terms of condition monitoring, you don't need much more either. You just really need an app service instance that hosts your dashboard. We're going to release a new OPC enabled dashboard next week at Achema Pulse. And then if you want to do predictive maintenance, Azure Data Explorer does that for you. It's a managed service, and I've recently blogged about how to leverage that with OPCUA data. It's linked there on LinkedIn. Okay, so the entire architecture, including what is required for building a digital feedback loop and machine learning and all that, is here. Just nothing's really changed there. We've been using this architecture for the last several years very successfully in lots of projects. So it's there for you to use, but again, start small and then gradually build up your architecture as you need it. So really, to sum up, step by step, we support at every step, and we have the services available to make that happen without locking you in to the Microsoft ecosystem. So that's the key for today. Thank you very much for listening.